Every now and then I find something on, a screw just fell out. Okay, every now and then I find something on Amazon that I just find to be so utterly, ridiculously unusable, or why does it exist, that I turn into a sucker and I buy it. So I can make videos about it like this. So today we're gonna test and see whether or not an active backplate cooler that's like universal that you stick onto your graphics card actually does or doesn't help temperature. The Be Quiet light-based PC case features a flippable design for either an upright or lay-flat orientation, cable trays and covers, and supports newer backside connector motherboards for a super clean build. Sleek and minimalistic design with integrated RGB lighting offers tasteful design cues, and radiators up to 420 millimeters are supported in the light-based 900 model. To see the full list of specs of the Be Quiet light-based 600 and 900, follow the link in the description below. Caution, sharp edges. Please wear gloves before operation. I was wondering why there were gloves in this because I already looked inside. I thought the gloves were to like somehow protect against like, I don't know, skin oils, but it turned, what are the bungees for? Whatever. The funny thing about these gloves is they never really are meant for guys with big old mitts like me. Well, you must have quit. They don't expect you to literally bungee strap it to it, do they? I guess they do, huh? Okay, whatever, sure. I hadn't really like looked through this product's reviews or anything. I just was like, what the heck? I don't remember how much it was. I guess I should probably look into that. But before we get there, okay, so it's got a very long fan cable because obviously it has to be able to plug into the fans or to, you know, something to control them. But this would actually be kind of neat if you used it. It's actually heavier than I thought it would be. This is kind of neat if you used it on a graphics card that maybe has a fan header, because then it would speed up and slow down with the GPU fans. I guess I'm not sure why they use a split cable all the way to the end. I guess they could have unified it up here and had a single cable, which would be easier to mount. As you can see, it's a black anodized aluminum. It's got two fans inside. It's a fairly decent size. This is the thermal pad. Okay, I'm not sure what this is for, because as you can see, you get no instructions. So you get alcohol wipes to clean the thing, big ass thermal pad, so that's kind of nice. I'm assuming this is cut to the size of the back. Yep. Okay, so pretty straightforward and standard. I don't know what the brush is for, sure, whatever. But I'm assuming that these two channels right here that are kind of grooved in there are for mounting down these bungee straps, which are very crude way of installing this thing. But yeah, that's what that looks like right there. And you literally are gonna zip tie it to your graphics card, but I guess you have to hope that on the other side, it doesn't line up with the fans or something that can become a problem with binding up in the GPU fans. And then I'm assuming the other one would fit right here in the middle, right? Now the thing I have to figure out today, okay, it doesn't even fit down in that channel right there. I'll probably end up going rubber band method, I guess, than using these guys right here. But what I need to figure out today is the appropriate graphics card for this. Because if I were to stick this on something like a 5090, obviously it's gonna generate a lot of heat. So here's the thing with the backplates, like if you go back to like the 700 series, 900 series NVIDIA stuff, that's when backplates started to kind of like become more prevalent and being pre-installed in graphics cards. But not everyone was going about it the right way. Some people were using, some brands were using it as an aesthetic piece where it did nothing but just make the back look pretty, but there was a standoff, and then there was no thermal pads or anything touching anything on the back of the PCB. So the radiant heat that would come off the back was just sort of reflecting off of the backplate back onto the PCB. And early backplates that were installed in that way were actually hurting temperatures of the graphics card because that heat could not radiate away from the card. It was being almost, not insulated, but it was being reflected back at the card. Then brands came along and started adding thermal pads to the backside. So you could, if you had RAM chips on the back, like big cards with a lot of RAM on them, 3090 had RAM chips on the back, right? Then you would have to do some sort of active cooling back there. Then they found that obviously heat radiates in a 360-degree pattern. So not only does having a cooler on the front of the PCB grabbing heat from like VRMs and chokes and the core and the RAM and all the SMDs and controllers and such, but they found that if they active cooled the backside, or even passive cooled the backside, then that heat on the backside could be more quickly pulled away from the component. So then the backplate became basically a big heat spreader. But when they're flat like they are, without any sort of a heat sink design or having, these channels and stuff, synced, if you will, then they became, pretty poor at their job. So then he started finding backplates that had kind of a design in them, maybe some channels and stuff cut to add surface area and a little bit of a heat sinking design aspect to them. So I could see where this might have a benefit to a card that's generating a lot of heat. The downside is if you throw this on something like a 5090, I don't think this has a chance in hell at being able to handle the amount of heat that can come off the backside, especially when we talk about a 600 watt card. So trying to find the right card to throw this on right now is gonna kind of be the challenge. I'm kind of feeling like 4080 is about where I would maybe max out on this. 4070 Ti Super, 4080, something like that. One, because of its size, and two, if this thing is not doing a good job at being able to pull away heat, then sticking this thing with a heat pad or thermal pad on top of the block or the backplate is just gonna be doing nothing but making it look ugly and slowing down that heat dissipation process, if you will. I'm also really curious as to how much air these fans could possibly move. I think it would have been neater if they were a little bit bigger fans. These are like 80 mil fans, they're pretty tiny. I think if you were to put bigger 92 millimeter, like Noctua type fans or something on top, blowing down through all of the heat sink rather than this pulling air in and centrifugal forcing it through the heat sink, I think that would have had a better aspect of cooling. There's also one other thing when you do it this way, because of the fact that this is gonna be, even though it is an axial fan working as a centrifugal fan, the air is being pulled down and it's gonna have to be forced to push straight out, right? So it's not gonna be able to push out in a 360, it's gonna be forced that way and that way. Well, this fan's also gonna be forcing air this way. So both these fans are gonna be colliding air in the middle and then it has to make a crazy turn up. And these are not gonna be very powerful fans. So I'm kind of not feeling this is gonna have a whole lot of a positive effect. That's why I'm feeling like a fan on top of this heatsink pushing down through it would have been better than trying to use an axial as a centrifugal fan. So it's kind of like a hybrid design, which I don't think is gonna work very well. Yeah, so here's what we're gonna do. I'm gonna go find a card, we'll install it real quick, and then I'll do some A/B testing to see if something like this is beneficial in any way. Because here's the thing. If you look at the size of this, it's not very big. So it's also not gonna have a whole lot of thermal mass or cooling mass capability, right? Or thermal cooling capabilities. So throwing on something really big, like a 4090, 5090, 4080 Super, whatever, is probably gonna have limited to any effect at all. But if you put it on too small of a card, those cards are all so power efficient these days anyway and generating such little heat, that makes this completely unnecessary. So it's kind of necessary for the big, expensive, power-hungry cards, but this particular design is limited. So it's kind of like, again, circling back to the opening sentence of this video, every now and then I find a product that just absolutely doesn't need to exist, and they've clearly gone through manufacturing attempts at this, which means there's cost involved in mass producing this. So let's see if I'm off base, or if this thing actually does anything it says it does. Well, it doesn't say it does it anywhere because it doesn't come in the manual or anything, but the ad. Oh yeah, and I guess what I started to do about 8 minutes ago was tell you guys what it cost, because I forgot. Because I ordered it and it came and then it went on the shelf and then I was like, oh yeah, that thing. And it was $35. That's actually more expensive than, damn. Okay, so I've got two 3090s here. I wanna see something real quick. This is the 3090, wow, it feels so small. Anyway, this is the 3090 MSI Gaming X Trio. And it's got a backplate, but kind of looking through it, it doesn't look like the backplate has a whole lot of thermal pads on the back touching things other than maybe the memory. If it does, then we'll use this one. Otherwise, we'll just use the Founders Edition card. I figured since they're calling out 3090, I might as well at least try it. Well, that's an earthquake.
Dang.
Really testing out them seismic supports above us, aren't we? It's California, the ground fucking moves, okay? Okay, so can I get this off without breaking anything? Let's see. Okay, yeah, see, they only had RAM. Oh, and a couple chips right there. So they only had RAM cooling on the backside. So I'm not gonna probably use this one because, get back on there. It's funny how they used a split thermal pad like this instead of one that was the right width. Because the VRMs are right here. Like there should be cooling on the backside of the VRMs on the pad. You see it obviously has a heat pipe, but yeah. So now looking at a Founders Edition 3090, this trim sits up higher than the actual piece that's touching the components underneath. So when I stick this on there, there's a pretty significant gap. I know this might seem like I'm just kind of harping on this, but this is a true example of a product that is not as universal as they make it seem. So we already talked about how the edges are higher on the 3090 Founders, which means that we're not going to get the greatest contact on the flattest surface. Not to mention we're going to be losing out on all this area that's too high. The 3090 MSI card doesn't touch the back of the core, so the core is going to be unaffected by any additional cooling. It's only touching memory, which means it might help with memory cooling. But again, all of this area here would be lost surface contact, meaning we're not going to be transferring any heat, and then we'll just be bouncing heat back at the core on the backside. So this is open on a lot of these graphics cards so that heat can radiate out. Like I said, we don't want to reflect it back. Here is a 3090 Ti EVGA card. As you can see, again, open on the back, so we're not bouncing any of that heat back at it. But this has sort of a heatsink design built into the backplate. And this is easily 1 millimeter to 1.5 millimeters deep, which is the same thickness as our thermal pad, which is a 1.5 mil pad, which means we're gonna have half of the amount of surface area here even touching the thermal pad, because we're not gonna be able to get it to conform down into all of those grooves and transfer any of that heat. So it'd only be touching the top part. So then we're gonna lose all the heat sinking capability of the valleys, if you will, and only cooling the peaks. So this is easily 50% less surface area touching based on just putting this on the backside with the thermal pad. But I found a card that I think might be perfect. It is the most basic 4090 gigabyte Eagle, right? This is like, I think it's an Eagle. I forget what it's called. Maybe it's not an Eagle. Doesn't matter. It's like the most basic card. When was the last time you saw a 4090 that was a 2-slot or 2.5 slot card, right? But look at the backplate. It's almost like this thing was actually made for it. It seems like it's gonna fit really, really well on there. The only thing I wish this card had was an actual fan slot to plug this into it directly. But what I wanna do real quick, just to make sure, is pull the backplate off, because I need to make sure that this thing even has thermal pads on it. So just these two diodes were cooled. This might be the smallest, jankiest 4090 I've ever seen. Well, okay, so I threw some thermal pads in the back of the VRMs, which probably isn't gonna matter. I doubt I can even see VRM temp on this. And then more importantly, I got one on the back of the core. So at least I can do some A/B testing to see if the core improves with or without it. But yeah, this is so much more involved than what this product was even advertising that should be necessary. But I need to make these results actually mean something. Okay, cool, I can feel it pushing down. All right, I'm gonna put this back together, run and chart out the stock speeds, and then run it all again. If you guys don't know this, Steel Nomad, the 3D Mark benchmark, has an Explorer mode and has a pause mode. So you can literally leave it in one scene, nothing moving, for ultra consistent locked frequencies and stuff. So we can actually use that to do some pretty good temperature testing on this guy. All right, so I've got my baseline done. I'm not gonna use their bungees. This just does not seem like a good idea to me. I'm gonna use rubber bands, but I figured I'd take you guys along for the ride on how to install this. So I like how it says professional screen cleaning paper. Anyway, we need to clean the backplate. Any residue that could be on here from anything, fingerprints and such. So alcohol wipes obviously are what's best for that. Now on the back here, you can see there's some machining oils and stuff. So we need to make sure we get all of that off, especially since I've been handling it. For multiple reasons. One, just good contact with the pad. And then two, we don't want to contaminate it with any of these oils. See, you can see there's oils all up on there. So I might even use some isopropyl alcohol on a towel on this. You can see spots where it's super shiny. That's just where it seems like there's all kinds of oil or something left on there. Yeah, Yeah, there's all kinds of oils left. Oh, I can feel it. Ew. Okay, I'm gonna have to use isopropyl alcohol in a rag, I think, because you can feel the oil on that. So already their own installation crap is crap. 35 bucks, huh? Oh, I'm the sucker in this one. See how much better that was? Jeez. Just okay. I ejecto coolered the hell out of that. Sure. And put it right here centered. Actually sticks pretty good, but we're still gonna use the rubber bands for good measure. That hits. So this thing go like that at an angle. Sure, whatever. This just looks like one of my crazy ghetto experiments, but this is a real product. Nothing says quality of a 4090, like bungees and rubber bands, but actually doesn't look terrible. Like it looks better on this card, I think, than it would have on the other ones. Okay, I've already done my baseline. Let's see if this helps any. Nothing says quality like red rubber bands on an RTX 4090 that cost a minimum of $1,500 when it was new. This is an MSRP model. There's no frills, and it probably still costs $2,000. Anyway, moving on, I have performed the tests, and here are the results. All right, so the blue lines here is the edge temp and the hotspot temp on the 4090. Yeah, we got hotspot temp on 4090. I forgot about that because they removed it from 5090 because NVIDIA doesn't want you to see how hot the damn thing really is on the inside. Anyway, I digress. You can see by the blue line here on our baseline, it is slightly higher than our pink line, which is with the active backplate cooler installed. Now the backplate cooler is set to 100% fan speed. They're running about 2,800 RPMs. Same thing with the GPU. GPU fans are set to 100%, power limit set to 111%, voltage curve was maxed out, so it was really locked down. So Steel Nomad, like I said, allows us to pick, like we can start the test and just pause it, and it will just sit there and continue to render that one frame. So it allows us to get really consistent back-to-back test. Now here's the thing, that right there, as you can see, even stock, so our max GPU allowed temperature is 88C on this particular GPU and the 4090 in general. You can see by the blue line we were nowhere near that because we were topping out at just over 72C with the hotspot and about 60C on the edge temp. In fact, if we took a look at our averages across the load, our average temperature on the baseline on the core was 58.85. Okay, so nowhere near the 88C. So already we don't need the backplate cooler. Our hotspot temp averaged 67.67. Now, if we take a look at the active cooler, you can see, yes, there was a slight decline of temperatures. Our average dropped from a 58.85 to a 56.75, so just over 2C or 2.1C exactly on our edge temp, and our hotspot jumped down from a 67.67 to a 65.34 or 2.3C. So, the question is, does that turn into any sort of practical advantage? Well, if we take a look at frequency, no, it doesn't. In fact, there are two lines right here. You just can't see because they are so perfectly overlaid on top of each other. You can kind of see at the start and at the end here. This is where the test starts, and then because the temperature climbs, we deal with some boost bin dropping. But it maxes out, it starts at just over 2650. It was like 2650, 2660 actually is where it started. And then it dropped down to an average of 2640 right here on this line until we stop the test, and it shoots up and then comes down. They followed the exact same behavior because the boost bin and the temperature curve are relational, and that happened exactly the same. Now 2C reduction, unless we're literally 1C away from dropping a boost bin, is not gonna be noticeable. In fact, you're not gonna notice one boost bin drop anyway. So as you can see right here, it had zero effect in the behavior of our card, even though it was noticeable on the graph for the temperatures, but you never would have noticed that anyway. So it's $35 wasted, as you guys probably have already deduced from this video, and I already deduced before I bought it, but I wonder. So this tells me even on a lower powered graphics card, we would probably have even less noticeable difference in temperature because there's just not that much temperature being, generated by those cards. Now, to be fair, yes, we do only have the small thermal pad on the back of the core. What would have been an interesting test is if I had another one of those big pads, put that under the backplate put the backplate on, and then the active cooler, where we could take way more heat from the back of the graphics card, transfer it to the backplate, and then see if the cooler can handle that. So, but again, as we showed, by trying to find even a card where this might have some sort of use was difficult because backplates are not universal. Backplates are not usually flat and smooth. There's lots of holes or gaps in them because graphics card manufacturers have kind of determined and discovered over the years that there's certain areas where it's actually beneficial to not have the backplate and just let the heat radiate away. It's just gonna be hard to find a use case scenario where that thing is actually very useful. Now, what I might try and do for a follow-up on this video, if you guys want me to do it, is see if I can source another one of these big thermal pads like that and just go ham on the thermal pads on the back of the card, where we're taking things like VRM temperature, and we're taking things like the back of the memory, you know, the pads of the memory can transfer heat out the back of the card, other SMDs, chokes, all that stuff, and we can try and get that heat out of the back side of the card. And that's to assume that the front side isn't touching those components, because honestly, heat is going to move to cold. Heat, that's the direction of heat transfer. That's thermal transfer. Hot to cold, not cold to hot. So with the cooler on the front, obviously active cooling those parts, most of that heat's gonna be moved to the front anyway. As you saw, 2 degrees went to the back plate, through transferring of a thermal pad, through a back plate, through a thermal pad again, through a heat sink, through 70mm fans that don't move a whole lot of air. So there we go. 35 bucks, well wasted. But it doesn't mean I might find a use for this somewhere else. I mean, it is a flat piece of aluminum with fans on it, so maybe you've got some sort of a, I don't know, not a hot plate, but maybe you've got some use case of 3D printing or something where this heatsink might make sense to you. I don't know. It has more uses than just on a computer, but what it's advertised for is a complete waste of money and it's garbage. All right, guys, thanks for watching. As always, we'll see you in the next one. If you've got any crazy things you've seen on Amazon, you're like, why does this exist? Jay, you should test it. Email me, tweet me, whatever. I like to look for this sort of stuff and see if it's actually useful. More often than not, it's not.